Welcome to a mini presentation about neurofeedback. Neurofeedback is an all-natural, non-invasive approach to stabilizing the brain. Over the course of this presentation, I'll be discussing what neurofeedback is, how it was developed, how it can reduce stress, and how this relates to clinical conditions like anxiety, depression, ADHD, PTSD, and symptoms related to an unstable brain. Welcome. Over the years, I've had many clients who have been curious with how neurofeedback works and want to know more about its origins and its development. So this is my attempt to answer some of those questions. My name is Christina Berard, and I'm the owner of A Mind of Your Own, where I offer neurofeedback and life coaching services. Here's a little bit about my background. I have a Bachelor's of Science degree in pharmacy from the University of Rhode Island, a Master's of Education in Counseling from Providence College. I did a residency in counseling at Interfaith Counseling Center. I have a certification in neurofeedback from the Institute of Applied Neuroscience in Asheville, North Carolina. And I did an internship in clinical neurofeedback at the Neurodevelopment Center in Providence, Rhode Island. On the next slide, I'll be sharing with you how my careers merged and evolved into neurofeedback. So why neurofeedback? I had been a pharmacist for 20 years and really enjoyed counseling my clients. I wanted to learn more about the mind-body connection and how stress impacts the body's own healing ability. So that led me to get a master's in counseling to better understand the role of emotions on health. Sometime later, I had a major car accident. A few months after that, I began experiencing significant anxiety, insomnia, and panic attacks. These symptoms were affecting my life significantly. I couldn't drive long distances. I became claustrophobic and avoided large gatherings. Being on a plane became an issue, as did shopping in large malls. I tried psychotherapy, acupuncture, physical therapy, massage, but nothing seemed to eliminate these symptoms completely. They did help, but they just kept me stable. Until neurofeedback. A friend of mine suggested neurofeedback. I kept putting it off until one day I finally scheduled the appointment. After a few weeks of training, the anxiety and panic attacks subsided and eventually disappeared, as did the insomnia. After experiencing these remarkable results, I was captivated. My understanding of drug therapy, coupled with my experience in counseling, complemented neurofeedback very well. I'm still a licensed pharmacist and use that knowledge base every day, but my focus now is on brain health and how that affects the body. Now that you've heard my story, let me share testimonials from some of my clients. These responses are the real reason I do what I do. First one is from a mom whose 10-year-old boy with anxiety, and it was pretty severe. The child couldn't even go from room to room in the house without having someone with them. And this is her testimonial. Neurofeedback changed my son's life. He is able to do activities he loves without the weight of his anxiety holding him back. Second one is another mom who had a 12-year-old girl with autism. She was on the spectrum. My usually silent child was talking calmly and clearly, talking with me telling me all sorts of things about what she was seeing on our ride home. And her daughter normally was not very talkative at all, and it was hard to get her to say anything. She did talk, but it was just difficult to get a conversation going. The third one is a 22-year-old man with anxiety and panic attacks. I used to have a lot of panic attacks and haven't had one since I started neurofeedback. So these responses, are really the real reason that I continue to do neurofeedback. It certainly helped me, and I feel like I just am paying it forward and giving back, and it's very satisfying. So first, let's talk a little bit about stress and how it affects us. Often, it's others who notice how stressed we are right before our bodies hit a wall and finally shut us down. So how does stress affect our bodies? If you look at the diagram, you'll find the hypothalamus, the anterior pituitary, the adrenal cortex, labeled to your left. The hypothalamus communicates with the anterior pituitary via releasing factors, and there are various. Then that sends signals to the adrenal cortex via the adrenocorticotropic hormone. And the cortex releases cortisol into the body, including the brain. Under normal, healthy circumstances, this feedback loop shuts itself down quickly, but with chronic stress, it continues to produce cortisol. So, stress can impair immunity, and you need to distinguish between acute stress and chronic stress. So this feedback loop is important in keeping us healthy, but only when it occurs acutely. So for example, if we have a stressful situation at work and we resolve it within, maybe a couple of hours, and you come home, you relax, and the stress is dissipated. So that is an appropriate reaction and response. What is unhealthy is when that stress continues and doesn't alleviate, and so that cortisol continues to be released. When that happens, we have decreases in levels of B and T lymphocytes. Natural killer cells are less responsive. We have decreases in IgA antibodies in the saliva. Cortisol is necessary for dealing with acute infection or inflammation, but chronic release of cortisol damages and kills cells in the hippocampus involved in memory and learning. Glial cells in the brain, which are the supportive cells for all brain functions, lose the ability to replicate. And then you have the deterioration of glial cells, which further weakens the immune system. So that was a simplistic overview of how stress affects the body. There's a whole field in medicine that studies the effect of stress in the body. It's called psychoneuroimmunology. It's the study of the interaction between psychological processes and the nervous and immune systems of the human body. Dr. Joan Borsenko has researched this mind-body connection and has written several books on the subject. She earned her doctorate in medical sciences from the Harvard Medical School, where she completed postdoctoral training in cancer cell biology. Dr. Candace Pert was an American neuroscientist and pharmacologist who discovered opiate receptor, the cellular binding site for endorphins in the brain. And she describes how stress affects the body in her book, Molecules of Emotion. All three of these books are excellent if you're interested in knowing more about the mind's role in healing the body and how stress contributes to disease. I just wanted to go further back and give you a little bit of history on certain scientific discoveries that had a significant impact on the development and understanding of how the brain can heal itself. Dr. Marion Diamond did breakthrough research in 1964 showing that the brain was capable of changing in structure and created new neural connections. She basically discovered neuroplasticity. She was one of the first scientists to study Einstein's brain, and she coined the term use it or lose it, referring to neural connections and brain health. Dr. Michael Merzenich demonstrated that neuroplasticity remains through adulthood something that was never considered possible. Until his research, the common belief at the time was that neuroplasticity only happened in the brains of young children. So let's look at the science of neurofeedback more closely. There's three concepts you need to know: neuroplasticity, operant conditioning, and mechanisms of subconscious neuromodulation. Understanding these three concepts will help you have a better grasp of how neurofeedback works. Neuroplasticity is the brain's ability to reorganize itself by forming new neuronal connections throughout life. Neuroplasticity allows the neurons, the nerve cells, in the brain to compensate for injury and disease and to adjust their activities in response to new situations or to changes in their environment. So why was this discovery important? Because of the research done by Dr. Diamond and Dr. Merzenich, we now know that experiences change the structure and the organization of the brain. This discovery contradicted and overturned what we thought we knew about the brain. In turn, this then led to new approaches to treatments, including neurofeedback. So these changes or adaptations in the brain that we call neuroplasticity can result in positive or negative outcomes. Meaning, if you, for example, adopt a new behavior and it's unhealthy, if repeated enough, it will eventually alter the neural connections of the brain, and it then becomes the default. In turn, it now becomes a default behavior, a maladaptive negative behavior. However, if you start exercising and that's repeated over and over again, that circuitry is now rewired, and the brain as well as behavior become affected in a healthy manner, and that becomes the default. So neuroplasticity is a good thing as long as we are mindful about it. Learning to play the piano is a good thing. Repeating foul language is not. Here's a short video clip that explains in simple terms what neuroplasticity is.
Not so long ago, many scientists believed that the brain did not change after childhood, that it was hardwired and fixed by the time we became adults. But recent advances in only the last decade now tell us that this is simply not true. The brain can and does change throughout our lives. It is adaptable, like plastic. Hence, neuroscientists call this neuroplasticity. How does neuroplasticity work? If you think of your brain as a dynamic, connected power grid, there are billions of pathways or roads lighting up every time you think, feel, or do something. Some of these roads are well-traveled. These are our habits, our established ways of thinking, feeling, and doing. Every time we think in a certain way, practice a particular task, or feel a specific emotion, we strengthen this road. It becomes easier for our brains to travel this pathway. Say we think about something differently, learn a new task, or choose a different emotion. We start carving out a new road. If we keep traveling that road, our brains begin to use this pathway more, and this new way of thinking, feeling, or doing becomes second nature. The old pathway gets used less and weakens. This process of rewiring your brain by forming new connections and weakening old ones is neuroplasticity in action. The good news is that we all have the ability to learn and change by rewiring our brains. If you have ever changed a bad habit or thought about something differently, you have carved a new pathway in your brain and experienced neuroplasticity firsthand. With repeated and directed attention towards your desired change, you can rewire your brain.
So neuroplasticity is at the core of neurofeedback. Neurofeedback takes advantage of neuroplasticity in order to train the brain into healthier, more functional patterns. It helps the brain adjust its timing and strengthens connectivity between the different parts of the brain. When we have a stable brain capable of coming in and out of a variety of emotional states, We can learn and retain information. We can respond appropriately in a given circumstance. We have the flexibility to adapt to a change, time constraints, or change of plans. A stable brain creates a more stable life. So the second term we need to understand is operant conditioning. It's a form of learning made famous by B.F. Skinner. It starts with voluntary behavior. It's based on the theory that a conditioned subject will modify or maintain its own behavior due to consequences of that behavior. Reward or reinforcement is used to maintain or increase a desired behavior, and punishment is used to reduce or eliminate a behavior. Very simply, if you reward a cat with food, it repeats the behavior that produces the food. When it doesn't produce the desired behavior, the food is withheld, and this is the punishment. The third concept is neuromodulation. It occurs when we get what we want from our actions, not when something is given to us. It occurs in response to successful mastery of an environment in meeting our needs. It's largely a subconscious process. The brain figures out the pattern on its own without conscious effort. Basically, this is learning taking place in the brain by the brain. So it's the capacity of the brain to learn something when it receives a reward for doing something that was asked of it. Neuromodulation occurs after the desired behavior is repeatedly reproduced. In a few slides, you'll see how all three concepts relate to neurofeedback. Neurofeedback is essentially a type of biofeedback. Biofeedback is a process whereby electronic monitoring of a normally automatic bodily function is used to train someone to acquire voluntary control of that function. So for example, we have ways of regulating heart rate and blood pressure and hand and foot temperature and even our breathing. And neurofeedback uses the EEG to regulate brain waves. So now that we know the basic scientific concepts, let's look at neurofeedback more closely. So let's get into the mechanics of it. What does an actual session look like? So first we have sensors, and they're placed on the scalp and ears to read the brain's electrical activity. The brain waves are displayed on the therapist's computer, and goals are set based on assessment of individuals' brain waves. When the brainwave activity meets the set goals, the client gets positive feedback, visual or auditory, to guide the success with the game. In my case, I use a movie. I find that more effective, but there are people that use games and find it just as effective. So the reward is the brightening of the screen, and the punishment is the dimming of the screen, and that's called operant conditioning. Through repetition, the brain figures out the pattern all by itself. This is the neuromodulation. In turn, over time, this new healthy brainwave pattern then becomes the default or automatic response of the brain, which is what is called neuroplasticity. I'd like to show you a short video by Michael Cohen that does a terrific job of making these complicated concepts more easy to grasp. Michael Cohen is the founder, president, and director of neurotechnology for the Center for Brain Training. Mike entered the field after neurofeedback helped his father with major depression. The depression hadn't responded to any medication or even ECT. When Mike discovered neurofeedback, he encouraged his dad to try it. The response was remarkable.
Hi, this is Mike Cohen. I first took my dad to neurofeedback in 1995. He was struggling with severe agitation. We went to top doctors, nothing worked. Then we found neurofeedback, and the effect on him was remarkable. Ever since, I've worked with neurofeedback. So when people ask, what is neurofeedback, they typically want to know how you do it, what it helps, and how it's different than other options. With neurofeedback, anyone can improve their brain. We've trained children, teenagers, and adults from age 2 to 92. For children, it's often used for ADHD, emotional and behavioral issues, learning and developmental delays, and struggles in school. For adults, it's commonly used for anxiety, depression, obsessing, and sleep problems. Neurofeedback measures brain activity, like brain waves, and it helps you make more or less of certain brain patterns. By changing brain activity, or by changing how one area of the brain talks to another, you can improve attention, control of your emotions, and behavior. There's research on how it helps migraines, pain, concussions, addiction, and seizures. But what do all these have in common? They're brain issues. With neurofeedback, your brain changes itself. And when it does, typically any of these issues improve. It's not all about problems. Neurofeedback improves performance by changing the timing of the brain. That can help anyone in performing in school, business, or sports. It helps give you an edge. Neurofeedback is different from brain games like Lumosity or tutoring or therapy. Those focus on changing your skills or behavior or how you think. Neurofeedback is focused on changing the brain. There are parts of your brain that help you pay attention, that help you be calm, that help manage your mood and your emotions, or that help you sleep. You don't realize how much your brain affects your mind. With neurofeedback, you get to see how changing your brain can have a huge impact on your life. How do you do neurofeedback? First, we put sensors on your head. Commonly, we measure your EEG brain activity with a special computerized system. The system gives you feedback, such as playing a movie or hearing a beep. For example, when you make a certain amount of beta brain waves, the movie will play perfectly. But as soon as you're less alert and awake, the movie starts to fade out. You rapidly learn how to keep the movie from fading out by changing the brain activity that's being trained. Your brain has a way of figuring out how to get the movie to play. Once you learn new patterns, and that may take practice, your brain tends to remember it. There's a lot of published research that shows that the brain learns from feedback and that measurable changes in brain activity occur after training. So how do you change your brain? It's just learning. Children learn to play a video game, and they never read a manual. Their brain figures it out. How do you balance on a bike and not fall over? Somebody probably showed you, but it's your brain that figured out how to balance. When you train brain activity, your brain figures out how to balance its own activity. So once you train the brain, does it stick? Well, you don't forget how to ride a bike, even if you hadn't ridden in 10 years. It's the same with neurofeedback. Once your brain learns, you don't tend to forget it. There are exceptions, particularly if there's disease like Alzheimer's or neurological issues, but there are still ways to train your brain. The changes you make with neurofeedback can over time have a profound effect on learning, memory, attention, mood, migraines, and far more.
That's the best explanation I've seen on neurofeedback. Now let's look at what we are actually training within the brain. Arousal of the brain, which is drowsiness versus hyperactivity, and it's on a continuum. We affect the sleep-wake cycle. So for example, insomnia, cognitive processing, learning issues and difficulties, sensory processing, learning and social tolerances. And, it affects the motor responses of the brain, things like penmanship, general movement, stiffness. It affects moods and emotions, helps to stabilize them and prevent emotional instability. Also affects memory and our capacity to learn and retain what we learn. There are 5 basic brain waves, and they're measured in hertz. So delta brain waves are 0.2 hertz to 3 hertz. Theta are 3 to 8 hertz. Alpha are 8 to 12 hertz. Beta are 12 to 27 hertz. And gamma brain waves are 27 to 100 hertz. A good laugh and a long sleep are the 2 best cures for anything. Delta brainwave frequencies. The delta state is associated with no thinking during deep, dreamless sleep. Renewal, healing, and rejuvenation. Immune system strengthens in the delta state. Many scientists believe this state to be the most beneficial. This is why sleep is so essential. So delta brainwaves should be low while awake. Excessive delta while awake can interfere with emotional and cognitive processing. Can also be associated with head injury. We can't solve problems by using the same kind of thinking we used when we created them. Theta waves allow us to think outside of the box. They allow and promote creative thinking. Both Einstein and Thomas Edison were known to take short naps in the afternoon and often found a solution to their problem afterwards. Theta brainwaves become prominent during relaxation and meditation. It's the first stage of sleep. Produces flashes of creative visualization through vivid imagery. You feel more open and connected to other people. The theta state heightens problem-solving skills that require creativity. It's associated with insight and intuition. Theta is briefly experienced as we climb out of the depths of delta upon waking and when falling asleep. Excessive theta is problematic when eyes are open and engaged in a task. It increases inattentiveness, increases distractibility, lack of focus. Individuals with ADD or memory problems often have high amplitudes or amount of theta. Alpha state is associated with being in the zone. Elite athletes produce alpha brainwaves prior to concentrated performance, shooting a free throw, hitting an important golf shot. They occur when we're awake but deeply relaxed. Studies have shown that alpha state has been associated with peak performance. In the alpha state, we learn, process, memorize, and recollect large sums of information fast. Fears, habits, and phobias begin to melt away. Sense of comfort, peace, and harmony. When we have excess amount of alpha waves, we can be spacey, unmotivated, inattentive, and depressed. Beta is a predominant frequency when we are fully awake and alert. It's needed for active awareness directed to the outer world. When we're focused, best frequency for tasks, enhances cognitive processing, improves sleep pattern, concentration, attentiveness. These cute meerkats on the right are a great representation of beta when it's balanced. This frequency is great when it stays in check. My brain is like an internet browser. 12 tabs are open, 5 of them are not responding. There's a GIF playing in an endless loop. And where is that annoying music coming from? Excessive amounts of higher frequencies of beta are associated with high state of arousal, excited, anxious, scared, highly stressed, tense, too much intensity, and body tension. So I hope you're beginning to understand that all brain waves are necessary, but their proportions, location in the brain, and time of day when they are present is what matters. So what were the beginnings of neurofeedback? Dr. Joe Kamaya researched alpha waves back in the 60s. He discovered that they are present when we're relaxed. The amplitude or the amount of alpha waves are higher in meditators. They're used for tension control, used in military to train intelligence officers to pass lie detector devices, and corporations like Xerox explored using alpha training to enhance creativity. Dr. Barry Sturman had been doing research on cats with the EEG to try to improve sleep. Although his sleep goal failed, he did discover a brainwave he called sensory motor rhythm, which occurred in cats when they were calm yet alert. NASA at the time was having issues with their fuel monomethylhydrazine causing seizures to some of the astronauts. They became aware of Dr. Sturman's research and asked him to come on board. He exposed his cats to the fuel and noted that only some developed seizures while others didn't. After looking into it, he realized that the ones that didn't had been previously trained to raise their SMR brainwaves. This discovery went on to treat certain seizure disorders. Dr. Sturman trained cats to increase their brainwaves through operant conditioning. He published clear data that brainwaves could be operantly conditioned. While working for NASA, he discovered that the cats that were trained with the EEG didn't have as many seizures when exposed to monomethylhydrazine. This technique, later known as neurofeedback, was applied to individuals with seizure activity. 82% demonstrated significant seizure reduction. Let's just briefly look at brain regions and their functions so that you can at least have a basic map of areas we target in neurofeedback training. The diagram on the left is a depiction of the lobes of the brain and their basic functions. On the right is a more detailed diagram of the 44 areas known as Brodmann's areas, and each area has very specific functions. The 1020 system that neuroscientists and neurologists use to identify locations for sensors on the scalp is based on this diagram. So if we look at the diagram on the left, the temporal lobe, generally speaking, is known for memory, understanding, and language. The frontal lobe is responsible for executive functions, thinking, planning, organizing, and problem solving, emotions and behavioral control, and personality. The motor cortex is movement, sensory cortex is sensations, parietal lobe, perception, making sense of the world, arithmetic, and spelling, and the occipital lobe is for vision. Now these are your basic functions of each area. It's a little bit more involved and more complicated than that, but this gives you an idea as to what the brain does and how it communicates each section with another. So there are various types of neurofeedback. The arousal model is the original form of neurofeedback. It is the model in which most research has been done to date, and it continues to be the most commonly used. So the arousal is, we start off from under-arousal versus over-arousal, and it's on a continuum. Examples of arousal, so you would start off with the extreme coma, deep sleep, drowsy, relaxed, wakeful attentiveness, agitation, and panic. Arousal expresses itself in activation of the autonomic nervous system. Measures include heart rate, respiratory rate, blood pressure, muscle tension, sweat gland activity, electrical brain activity, as well as emotional and physical symptoms. So what is the optimal arousal? The right amount of theta and alpha can make you feel relaxed and calm. Excuse me. Too much at a certain time of the day can make you feel drowsy and inattentive. The right amount of beta during the day can make you feel calm, alert, focused, but too much can cause anxiety, frustration, panic attacks. So basically, with arousal, we're aiming for constructive optimum tension. So we don't really want to be too low on the left, which is associated with either being asleep or being depressed or groggy, or too much on the right, which is associated with having anxiety, frustration, or panic attacks. So what we can see from the bell curve there is that arousal needs to be appropriate for the task at hand. If you're taking a break at work, you want less arousal than if you're working on a task that requires attention. Ability to regulate arousal is key. You want to be able to adapt as needed to the situation at hand. A stable brain regulates arousal well. So what are the clinical applications? Neurofeedback can help with epilepsy, ADHD, addiction, PTSD, anxiety, depression, traumatic brain injury, migraines, panic attacks, mood disorders, anger, affect regulation, peak performance, conduct disorder, and autism. So what do all of these conditions have in common? A destabilized brain, a brain that's unable to regulate itself. By regulating a brain's arousal, you stabilize the brain. When the brain functions better, other issues improve or heal altogether. So if you look at the studies, you'll find that the majority of individuals respond to neurofeedback training. There's about 10% that don't. No one really knows why. But I think Homer Simpson would probably not be a good candidate. This is a list of physicians, psychologists, and researchers who are involved in clinical neurofeedback. Dr. Ed Hamlin, Center for the Advancement of Human Potential. He's in Asheville, North Carolina. Dr. Larry Hirschberg is at the Neurodevelopment Center in Providence, Rhode Island. He's affiliated with Brown University. Dr. Bessel van der Kolk is out of Boston, I believe, at the Trauma Center. Seaburn Fisher is a guru in neurofeedback therapy and developmental trauma, and she's based out of Northampton, Massachusetts. Michael Cohen is at the Center for Brain in Florida, and Dr. Paul Swingle is at the Swingle Clinic, I believe, in Vancouver, Canada. In addition to the books I've already recommended on psychoneuroimmunology, here are a few books that I highly recommend if you're interested in learning more about neurofeedback and getting more in depth in how it works and what kind of conditions it can treat. So, A Symphony in the Brain was written by Jim Robbins. He's an award-winning journalist and science writer who has written about his own experience with neurofeedback and explains brain science in simple terms. Highly recommend it to start off with. He's a great writer, so it reads really quickly and easily understandable. I mentioned Dr. Bessel van der Kolk up at the Trauma Center in Boston. The Body Keeps the Score is an excellent book for anyone who is dealing with trauma of any sort. He has different categories that he touches upon, and one of the chapters he writes about neurofeedback, but there's also other chapters on EMDR. It's an invaluable book for anyone that wants to know more about trauma and its effects on the body. Seaburn Fisher, again, she is a guru in neurofeedback. She's out in Massachusetts at Northampton. She wrote Neurofeedback in the Treatment of Developmental Trauma. Also very easy to read. She's a great writer and full of information. Getting started with neurofeedback is more for the person that is intrigued, is already a mental health counselor or psychologist or clinician that is interested in adding neurofeedback to their practice. So neurofeedback is an effective tool, but it works well in conjunction with a healthy lifestyle. So drinking plenty of water during the day, vegetables, fruits, whole grains, protein, healthy fats, optimal vitamin D levels above 40 and less than 100 nanomoles per liter is important. Vitamin D especially, healthy levels are associated with a decrease in mortality overall, but it's specifically important for brain health, strong bones, and a healthy immune system. Vitamin B12 levels are important as well. They should be above 400 picograms. And adding yogurt or some form of probiotic and prebiotic to your diet is really important. More and more research shows that it plays an integral role. A healthy microbiome plays an important role in brain health. These bacteria produce certain neurotransmitters and improve the immune system as well as gut health. So in review, neuroplasticity is always at work for better or worse. We can tap into the brain's plasticity in order to improve its functioning. Arousal regulation is the key to better brain function. There are no good or bad brain waves. They are all significant, and proportions are important. brainwaves can be trained. Neurofeedback training is an all-natural approach that teaches an individual to regulate their own brainwaves, which stabilizes the brain and in turn alleviates or heals conditions like anxiety, ADHD, depression, PTSD, and other symptoms related to an unstable brain. There have been many studies done on neurofeedback, and research continues to be done. I have a list of studies on a variety of conditions. If you'd like a copy, email me at berardcristina@gmail.com, and that's Berard, Christina with no H, @gmail.com. So thank you for taking the time to learn about neurofeedback. If you have any questions or would like to make an appointment, please contact me at berardcristina@gmail.com or call 401-486-5642. Thank you for listening, and remember, the mind-body connection is powerful. You can take advantage of it in order to heal your body and mind. Neurofeedback can be a powerful tool towards a well-balanced life. You can also visit my website at www.amindofyourown.com. I hope you've enjoyed learning about neurofeedback.